Okay, hi everyone. So we're doing area and circumference of circles today, and we're also going to get on to the area of sectors and the arc length as well. So we've got a starter here. We've got our two formulae that you'll need for today, which is the one on the left, area of a circle is pi times the radius squared, and on the right we've got the circumference equals pi times diameter. Okay, so have a go at these ones. The red one's the easiest, yellow's a bit harder, green's a little bit harder again. Okay, so assuming you've paused on how to go, we've got our three sets of answers there, and we're going to go through how we could have got this. Okay, so if you want to treat this as a bit of extra practice, you can do. If you want to just have a go and sort of go through as I do it, that is fine as well. So what we're going to be doing, this is just the kind of more basic circle questions, finding the area and circumference of circles. So again, we're going to be using pi r squared for the area. So the radius is the section going from the centre to the edge. So this is our radius, in this case it's 4 centimetres. So we start off with pi r squared, so pi times the radius squared, and then substitute in r is 4, and then so we've got pi times 4 squared, so that is 16 pi. And then if it's a calculator paper, you would put that in your calculator to see the answer. The other sort is circumference, so that is pi times diameter. So the diameter is the full way across the circle going through the centre. So it's 2 lots of the radius, and the radius being 4, we've got 2 lots of that, so that means overall the diameter is 8. So our circumference then is pi times 8, which would be 8 pi. So these are kind of the more basic ones. Basically for area you've got the radius, so you do pi times radius squared. For the circumference you've got the diameter, you just do pi times diameter. So it's just following the formula really, so there's 3 extra ones for practice, and then the answers will pop up on the next slide. Okay, and here's the answers for those ones. Okay, so on to the more challenging circle questions. We're going to be looking at area of sectors and the arc length of a sector. So what we've got here is a sector. It's basically like a slice of a circle. So sectors, basically think of it, if it was a pizza it'd be a slice. So what we've got, we're told the radius here is 6 centimetres. We're told that this is a 90-degree angle. How would we work out the area of this shape? Well, so while we don't know how to work out the area of a sector yet, we can work out the area of the full shape. So if we had a full circle, the area would be pi r squared. So we'd do pi times 6 squared, which would be 36 pi. So that's the area for the full circle. But what fraction of a circle have we got here? We've got a 90-degree angle. 90 degrees is a quarter of 360. So we've got a quarter of a circle. So what we would need to do to work out the area of our quarter circle, so I'll just try and draw that, it's not very neat. We would do a quarter times, and then our area from over here that we worked out with the full circle, 36 pi. So a quarter of that would just be 9 pi. So that would be around about 28-ish. I don't have my calculator with me, around about 28. Okay, on to a slightly more hard one. How would we do it for 60 degrees? So again, same kind of idea. We need to work out the area of the full circle, but then we need to work out what fraction of the circle have we got here. So we know that the full way round, we know that's 360 degrees for the full thing, but we've only got 60 degrees. So to work that out, we can do 60 divided by 360, so this is 60 out of 360. So we've got 1/6 of a circle. Okay, so same idea again, let's work out the area of the full shape. So we're going to do pi times radius squared, so there's pi times 8 squared, so that is 64 pi. So that is the area of the full circle. but we want a sixth of that. So the area of our sector is 1/6 of 64 pi. So that'll be 10.6 recurring pi. So that'll be, just get my calculator. We've got 33.51. So again, if you didn't have a calculator, you'd be fine just to leave it as what I've got here, 64 pi over 6. You would simplify, so that would be 32 pi over 3. But if you don't have a calculator, fine to leave it in terms of pi. If you do have a calculator, going through and doing it like this. So actually substituting in pi. Okay, so the hardest sort of this, we're trying to work out the area now when we've got a not nice round number angle. So we've got 53 degrees here. So what we need to do is work out what proportion of the full circle we've got. So what we did on the last slide when we had 60 degrees, we said we knew that the total was 360 and we knew we had 60 out of it. Well, now same idea, we've got 53 out of 360. So that's what proportion of the circle we've got. So when we work out our total, we're going to do that fraction of the area of the full circle. So first thing to do, work out the area of the full circle. So it's pi times r squared. So pi times 4 squared. So it's 16 pi. So now what we're going to do, we've got our area of the full circle. We know we've got 53 360ths of the circle. So we need to times them together. So 53 over 360 times by 16 pi. So that will give us 7.4 would be your answer for that one. Okay, so just in the area of the sector, so don't worry about doing that. For the arc length, what that is the length of this outside section. So what we would need to do to work out that is again working out the full circle, but we've only got a fraction of that. So we work out what fraction we have and then we times it by the full amount. So circumference, the full circumference, we do pi times diameter. So in this case it's pi and then the diameter is 2 times the radius. So it's pi times 8 pi. So that's the circumference of the full shape, sorry, the full circle. In order to work out just this fraction of the circle, we need to do 53 over 360 times by the circumference. So we're going to have to do 8 pi times 53 divided by 360, which will give us 3.7 as our arc length. So similar kind of idea, you work out what fraction of the circle you have and then you just work out that fraction times by whatever the full amount would be. Okay, so if you want to pause and have a go at this one, we've done the key skills that we need for this one so far, so if you want to practice, pause and have a go. You will need a calculator for these as well. Okay, so we've got an angle of 237. So the fraction of the circle we have is 237 times by 360. And we've then got our pi r squared over here, so this is the area of the full circle. So we substitute them in together and we get 79.46, so that would be the area. For the circumference, it's the same fraction, 237 out of 360, just now we're doing pi times diameter instead, because this is the circumference. So we substitute that in and we get 25.65. Okay, so this is kind of the general rule of what we've done. So here we've got a sector, and it's got this angle here. This is a Greek letter theta. So we've got theta degrees. You could use x if you prefer. I'll use x. So we've got x out of 360. So that is what proportion of the circle we've got. So let's say x was 180. We'd have 180 out of 360, which we could then simplify to a half. So our general rule, if we've got a sector, we do x divided by 360, and then times by, if we're doing the area, we times by the area of the full shape, which is pi r squared. If we're doing the arc length, we do x over 360, which is the fraction, times by pi times diameter. So that is because this is the circumference of the full shape, this is the area of the full shape. So we're just working out what fraction we've got and then timesing that by the full amount. Okay, so if you want to check this before you have got the questions, so this, what we've done so far is sheet 1 of the main task. So if you want to have a go at sheet 1, go ahead and do that before you look at the second bit. So part 2 of the lesson, we're going to be looking at the kind of more difficult questions of this sort. And here's the answers to this one. Okay, so go ahead, have a go at sheet 1, see how you're getting on with it. Check the answers as well as you go along, check you're getting them right. You may be out by some decimal places depending on your calculator, so just make sure you're rounding correctly, but make sure you're rounding the same way as the answer has. So if it's to 1 decimal place, round yours to 1 decimal place. And here is the answers, so check the ones you've done. I'll also put them up on Firefly as well. Okay, so the second sort of questions that you'll quite commonly see with arc lengths and sector areas is working backwards from the answer to work out the angle. So what we've got here, we've got a sector and we're given the arc length is 2.54, the radius is 3.2, but we're not told what this angle is. So what we're going to need to do is we're going to have to work backwards. So if we remember our formula for the arc length, we do x over 360 times by pi, and then times by diameter, but I'm going to do times by 2r. So we've got r, oh in fact, sorry, this is arc length. So we've got the arc length, we've got r, so there's only one thing in this equation that we don't know, and that is x. So what we need to do is rearrange this formula to get x on its own, and then we'll be able to work out what x is. So we start out, we write out the formula, so that L, so that's arc length, it's theta over 360 times pi times diameter. So theta is this angle, so I'll just change that to a theta. So then we substitute in what we do know. So we know the arc length, we know the diameter. We still don't know theta, so we leave that as theta. And we can then start to rearrange. So we divide by 6.4, divide by pi, and then times by 360, and we get our answer. So the idea is the same, this formula we're using is still the same. All we're doing, we're rearranging the formula to get a different thing as the subject. So we're starting off with the answer from before, and then we're working backwards to work out the angle. But the formula we use is still the same, you'll just have to rearrange it. Okay, so this one we're doing the area. Again, idea is very similar to before, we're going to use the same formula. So we've got area equals, so it was theta over 360, where this is angle theta, times by pi r squared. So we start off with the same formula we did before. The thing is, this time we know the radius and we know the area, it's the theta that we don't know. So we substitute the things we do know in, we then divide by 7 squared, divide by pi, because remember we're trying to get theta on its own, and then times by 360. And there we have our angle theta. So same kind of idea, the key thing is we're just substituting in and then rearranging to get whatever it is we don't know, so theta or x, depending on which you prefer to use. Okay, so that's how we do the second sheet's worth of questions. So go ahead and have a go at them. Again, I'll put the answers up on the slides, but I will also put them up on Firefly, so you can either look at the sheet or carry on watching the video, whichever you prefer. Okay, so here's the answers to the second one. So hopefully you got them right. I've also attached some extension questions on Corbett Maths to the Firefly one. So with those ones, I don't think you'll generally get in Year 9 ones that are harder than the workout section. So if you do want to really push yourself, you can have a go at the apply section, but if you struggle with them, really don't worry, they are a bit above what we need at the moment.